Okay, so Natarajanji, shall we start?
Still 4 or 5 participants has to come. I think only 8 people are there.
Okay. Let us wait for some more minutes, then we can start. So today I will be with you till 8:30,
First session.
first session, and then V Raghavan sir will take the second session. Today we will have in my session we will have a very deep look with examples on value stream mapping.
Value stream. Yes, sir.
And I am very glad to say that we have developed the necessary basic knowledge about what do we mean by the cycle time, lead time, value adding, non-value adding. All those concepts are very much required before we can plot the value stream map. So that we had discussed in great detail yesterday, and that will help us a lot today in understanding the value stream map. Value stream map, as such, is one of the very core tools, one of the very fundamental tools of lean methodology, and every lean champion, every lean expert, every lean consultant must be extremely competent in creating, and not only in creating, but also in being able to train people how to create a value stream map. So that is something very important. So in this course, which is for very senior professionals like all of you, please come on cameras. Paras ji, Seva, Sampat bhai.
Yes.
So good
Good evening, sir.
evening, good evening, good evening. How are you people doing?
Yeah, good.
Okay, that's great. That's great. That's great. Okay, so as I was discussing, since all of
Good
us
evening,
are
sir.
very good evening, sir. Bhai. All of us are very senior professionals. So there are two facts that I would like to really underline before we deep dive into the concepts. Number one, we are not only trying to learn how to create and interpret a value stream map, but please pay attention that as we grow senior, we will also need the competence on how to train our people to not only be able to create value stream map, but also how to interpret the value stream map and how to identify the opportunities for improvement that we can uncover while we create our value stream maps. Is that clear to all of you? Show me a thumbs up. So we learn how to interpret, how to understand, and also we will try and gain that competence, that how to train our own people. Because as I have been discussing from my very first sessions, that lean is as much as a people skill as it is a technical skill, right? So in lean, we want to involve everyone. We want to uh, make everyone a problem solver. We want to make everyone a contributor. So that's all we will also learn. And also, I must thank all of you for being so very interactive, and based on your inputs, especially from Paras ji, from Natarajan ji, from where is ma'am? Tirumala, Sampath, Varun, Siva, Shova ma'am. So based on all your inputs, we have been able to create such a nice interactive discussion, which is helping all of us, Prasanna and Sampath bhai. All of you have been contributing, and therefore these sessions are so good, right? It is not only because it is a one-way monologue or we have created some that you can anyway find on internet, right? There are so many write-ups, best of the best write-ups are there, you can read there. But what really adds value is, my dear friend, the discussion we have here. Yes or no? Show me a thumbs up. And please make sure that we will have lots of discussion around the topics that we are really trying to understand and become masters of. So the key gain, the key take away from these sessions is these interactions with all of you. right? That's what will make myself more richer in terms of knowledge and experience, and the same goes for everyone, right? So let us deep dive into the concepts of value stream mapping. I will start with a presentation. Where is that presentation? Yeah, it is here. Okay, so hope all of you can see my presentation.
Yes, sir.
Okay, perfect. So slideshow from beginning. Very good. Okay, so now, my dear friends, we are ready to understand this extremely effective tool of value stream mapping. I needless to mention that when we really start our activities as lean improvement initiatives, the first thing that we do on shop floor is going for a 5S exercise. Yes, that's what we discussed. That's what we discussed, Natarajanji. That is
Yes,
what will
yes.
create a very positive environment that will demonstrate that these ways of thinking, these ways of working really produce results. So that goes a long way in convincing everyone and also in creating a demonstrable improvements within no time on the shop floors. Having said that, now I would like to draw the attention of all of you that for gaining a deep insight into the process, what is really happening, where are the wastes, how we can improve the process, all this learning comes from this very first activity of value stream mapping. Varun, Paras bhai, can you see that? So this is how we start understanding process. Because every process is going to be a unique process. Yes or no? We are not as consultants. We will be helping lot many industries. Every industry, every business vertical will have a completely different, a unique process in itself. We cannot expect and believe that we know each and everything about each and every process. Yes or no? So, isn't it obvious that we will have to develop a very deep insight into how the material flows, how the information flows, what are the sequential activities, what really happens inside the process. If we start understanding that and we are able to create a visible map of this learning, which is demonstrated on the shop floor, don't you think that is the perfect way to start? Show me a thumbs up, right? And hope all of you have seen. And I sincerely believe that most of you have had exposure to how to create value stream map and all. So then it is almost always created all either on a big wall or on a big table with lot many post-its, and all the processes are drawn so that as a team, please underline my words, as a team we understand what exactly the process is, what are the process stages, and then as we deep dive into the value stream map, we gain more and more insights, as you will very soon see here. So starting from the very basics, my dear friends, just as Six Sigma methodology is also known as DMAIC methodologies. What are the 5 phases? Define, measure, analyze, improve, and control. Akanksha, yes or no? That is what we have learned from Dr. GSK, Dr. RKV Raghavan sir, Vinod Shankaran sir, all of them. Yes. So it is a structured methodology which starts with define, then Once we are able to define, then we go to the next phase, measure. Then we go to the next phase, analyze, and so on. So this happens in this particular sequence only. 5 phases of Six Sigma improvement methodology. Similarly, 5 phases of lean implementation methodologies are also there, and they will also happen in exactly the same sequence, not in any random sequence. Natarajan ji, Parimala ma'am,
Yeah,
Varun bhai.
define, measure, analyze, improve, and control.
Yeah, those are the 5 phases of Six Sigma improvement methodologies. Now I am introducing you to 5 phases of lean implementation methodology, and they are there on your screen right now. What are these 5 phases? Define value. Then next step is map the value stream. Third step is create flow. Fourth is establish full system. And then fifth is pursue perfection. That is always aspire for better and better processes, better and better results. So can you now see, just as Six Sigma methodology is having 5 phases, sequential improvement methodology, Sampath bhai, Paras bhai, Mani, Siva, Shakti,
Yeah.
Sova ma'am, Parimala ma'am,
Yes, sir.
exactly in the same manner, and we will have to go step by step and exactly in the same manner, and you will see the beauty. And I personally am more convinced with the methodology of lean, because within excellence team, Dr. GSK, Dr. RK, they are more of statisticians, and they are more in favor of Six Sigma. I am more of a really common sense approach, and I am more in favor of lean methodologies. So can you see that lean is so customer focused? It always starts with saying that first step, please identify what is the value from the perspective of the customer. So it keeps reinventing the value. It keeps reinventing and re-understanding and refreshing our understanding of what customer wants. Can you see that beauty? We are not only fixated with what we have been offering to the customer. We continuously try to find out what exactly is the value. That is where we start, which is the phase number 1, which is called define value. Once you have defined value, what does that mean? Parimala ma'am, Shova ma'am, Akanksha ma'am, what do you mean by define value? That this is exactly what, these are exactly are the characteristics of your product or service that the customer wants. Yes or no? That's what is the meaning of defining value. Varun, Paras bhai, Shiva bhai, Shakti bhai, Mani.
It is nothing but identifying the waste.
No. Slightly different. Slightly different. We will come to identifying waste when we will be mapping the value stream. Natarajan sir, when we are talking of defining value, we are really defining what exactly customer wants.
Addressing the pain point of a customer. If he needs a solution, he needs a benefit, he
Yes,
needs a service.
yes, exactly. So what exactly customer wants, that is understood in the defined value. And just as ma'am has very correctly added, this also includes identifying the pain points of the customer.
Also fixing the takt time.
That also will come to that, sir. That also will come to that, right? So first phase is defining value. Number 2 step
sir.
is then we map that what are the sequence of operations we carry out to create that value for the customer. That is what is called mapping the value stream. It is nothing but making a pictorial, visible depiction of our sequential steps that we carry out for being able to provide the customer the product or service that he or she desires. This, Natarajanji, is also the phase where we are able to identify the defects, as you very correctly pointed out. Yes, Natarajanji, when we are mapping the value stream, we will also get to see where are the wastes involved. Now, as the third step, we go and create flow. Yesterday we discussed, and hope you will recall, that if there is a large difference between the cycle times of various processes, can there be a flow, Parasji, Sampatji? If there is a vast difference between, let us say, cycle time of process 1 and cycle time of process 2, the flow will be affected. Yes or no?
Yes.
For
Yes, yes,
achieving
yes.
a smooth flow, all the cycle times must be more or less equal and equal to or less than the takt time. Yes, that is exactly what we discussed. Sampatji, Parasji,
Yes.
Natarajanji, Shobha ma'am,
Yeah.
Vignesh,
Yes, sir.
Varun.
Yes, sir.
Yes, so for creating value, for creating flow, we will have to for creating flow in the third step, we will have to understand what exactly is the takt time, and also we will have to make sure that the whole process beats to the takt time, and that
So
is
by line balancing, the flow can be created.
exactly very good. By line balancing, flow can be created. Excellent example. So here, and in addition to line balancing, I will also like to add one more aspect. It is not only about line balancing, which is fundamental and foremost, just as Natarajan sir has mentioned. Also, this has to be in sync with the takt time. Yes or no? And that is why it is sometimes called that it is like the baton of someone who conducts a symphony. Yes, Philharmonic symphony. So, according to the baton of the person who is conducting that symphony, all the musical equipments perform. Yes or no? So, depending on what is the takt time, all the cycle times have to be aligned. Then, for creating flow, we have understood that we are talking of a uh, pull system, which kind of ensures that there is no unnecessary inventory. Hope all of you have discussed that, understood that, the JIT system just in time, which makes sure that there are no unwanted, unnecessary inventory in the
Flow. Line.
in the pipeline on the shop floor. Yes or no? And for that there are various mechanisms. The most popular and very effective tool is that of Kanban, the visual communication cards. Yes or no? So with these, we then continually keep striving for making our processes more and more efficient, more and more effective. So hope you will now never forget these 5 step methodology of lean implementation. What are those, Natarajanji? Can you please read those out from the screen?
Yes, sir.
Can you please help all of us just have a revision of all the 5 steps?
Define value, map value stream, create flow, establish pull system, pursue perfection.
Perfect. Thank you very much. So, this, my dear friends, is one example of value stream mapping. It is also known as material and information flow. Why? Because it will talk of how the material flows, as well as it will talk of how the information flows in the system. So, from now onwards, whenever somebody says value stream mapping, you also hear that it is also known as material and information flow. That will remind you that it is not only talking of the material, but also it is talking of the flow of information. Can you see that? All of you, please
Your
confirm.
voice not clear.
Just a minute, just a minute. I am
The-
trying to. I am.
We can't hear you.
Yeah, yeah. Now can you hear? Yes?
Yes.
Okay, perfect. So, my dear friends, can you see? So, this is a very simple pictorial depiction of your value stream map.
Sir, kindly zoom this picture because very tiny. I was
Yeah,
not able to
definitely.
read.
I will zoom. In the next slide, it will be zoomed, right? Now, can you see that here there is information flow? So the customer places an order. Can you see the customer doesn't give anything which is in physical form, right? He is just giving some kind of a information when he's placing some kind of a order. It is the information. From the customer, the information is coming to the production control. From the production control, again, the information is going to our suppliers. Can you see these symbols? This symbol, some kind of electric. So this is used for information, depicting the flow of information. So in this, you are flowing the information. Then there is flow of material.
Sir, the customer and supplier having the same designing like symbols are the same.
Yeah, no problem. Yes. I will just try to zoom in. This is the zoom in thing. Okay. Now, can you see here, my dear friends?
Yeah.
Information coming from the production control to the supplier. Yes?
Yes.
Now, so do we give something which is into physical forms? Do we give goods to the supplier? No, we give instructions, right? That is information. So that is given to the supplier. From then, goods come to us. Here, the most typical components of your value stream map are these boxes. These are known as data boxes. What are they called? Data boxes. And this
What that
is
means, sir? Spell
DATA, data, yeah? Data. These are known as data boxes, and this is, my dear friends, your lead time ladder. We have understood all these yesterday. This is our lead time ladder. I will explain in the next slide. Now, is it better visible? Yes?
No, sir.
No? So I will zoom in. No problem. I will zoom in. So this concept is clear to everyone. This is talking of information flow and this is talking of material flow. Let me zoom in. So first let us have a holistic view here. How many processes are there? Process A is there. Process B is there. Process C is there. Let us have a deep look at the data box of process A. Yesterday we discussed all this. In process A, when we study the process, can we find out the cycle time? Paras bhai?
Yes.
Yes. Suppose the cycle time that we have calculated is 300 seconds, which is written here. What does that mean? This means, Shiva bhai, that this process A throws out one piece every 300 seconds. Yes or no?
Yes.
That is exactly what we discussed. Please confirm. Please show me a thumbs up. Please show me a thumbs up. When we say the cycle time for process A is 300 seconds, that means this process throws out one piece every 300 seconds. Also, another implication of this, that one particular piece spends 300 seconds while being processed at the process A. Paras, Natarajan, Shiva? Yes, both these concepts, both these way of saying, interpreting the cycle time are clear to all of us.
Yes.
First, that it will throw out a piece every 300 seconds. Show me a thumbs up. It will throw out a piece every 300 seconds. Natarajanji, show me a thumbs up. Every 300 seconds, it will throw out a piece. And another interpretation of another meaning of this, that any particular piece will spend 300 seconds on this process.
Process.
Yes, Both these concepts are clear to all of you?
Yes.
Perfect. What does this mean? CO, change over time. So during these two, whenever a changeover happens, average change over time for this process is 60 minutes. That's why we have observed the process. Now can you see that before even plotting the value stream map on a piece of paper, we will have to go and very minutely study each process stage. Can you see that? It is not just a very shallow exercise. Shova, Varun, Sampath, Shakti,
Yes.
Udayvani, can you see that? It is not a shallow exercise. Being able to know
Yes.
that what is the cycle time, being able to know what is the average change over time, being able to know what is the average uptime for this machine. Yesterday we discussed. Day before yesterday also we discussed. What do we mean by uptime? Uptime as against the
Available
downtime.
time minus
Yes.
available time minus downtime.
Available time minus downtime. And I also mentioned repeatedly that changeovers and setups are from within. They are part and parcel of the uptime. That is what the definition is. Yes or no? So we have studied the process and we have realized that the downtime is 20% here for this machine on an average. So this study goes on for 3-4 days. You cannot really comment on one day's performance. Bharati, Varun Bhai, Shakti, can you see that? We will have to study this machine or this process stage for 3, 4, 5, 6 days. And then we can say, Bharati, do you agree with that? On an average, the changeover takes 60 minutes. On an average, the uptime is 80%. And this machine is being run for 2 shifts and these many seconds are available. All that we discussed. So this is how we create a data box. Here also we have understood that there is a WIP bin just as we discussed yesterday, and in this WIP bin how many pieces are there? Let us say 1000. Yes, and then let us now look at the process B. Who will answer me? What is the cycle time?
45
45
seconds.
That means after how many seconds it will throw out a piece?
45 seconds.
45 seconds. Also, please tell me how much time one particular piece will spend on this machine?
45 seconds.
45 seconds. And also, please tell me, is the line balanced right now?
No.
No, because this is throwing out one piece every 300 seconds, whereas this machine is capable of processing one piece every 45 seconds. But will it
Yes.
be? Please tell me, will it be processing a piece every 45 seconds?
No.
No, because this is the
We don't have
feed is
input material.
the rate of feed is only every 300 seconds. Therefore, this machine will be starving. And typically, people who are not so very initiated into this, what do? And they mistakenly think that we have corrected the problem. They create a big inventory here. Can you see that? One apparent and, in my opinion, a wrong solution to solve that problem is to create a big bunch of inventory here. Can you see that? So that this machine is continually fed. So until unless you are creating a built up of inventory, this machine will be starving. So in a single piece flow, Parasji, Natarajanji, yesterday we took that example, Varun. In a single piece flow, this machine, the process B, will be starving. Yes or no? All of you can see that?
Yes, yes.
In a single piece flow, this process B will be starving. Now, look at the process C. Who will answer me now? Varun. Varun, what is the cycle time for process C?
300 seconds.
300 seconds. That means after how many seconds this process C throws out a piece?
Every 300 seconds.
Every 300 seconds. That means one single piece, how much time is spent on this process? 300 seconds. Also, can you see that the The average changeover time for this machine is
4 hours.
240 minutes. Yes or
240
no?
minutes.
240 minutes. Also, can you see that the uptime, the machine is quite healthy? Please see, this machine is quite healthy. We are developing based on these data boxes where the opportunity for improvement exists, right? And for that, I want all of you to be very, very attentive. This machine's health is quite good. Why, Varun? Because the uptime is
100%.
100%. So this machine is not prone to breakdowns. The machine health is quite good. But in this machine, where is the opportunity for improvement? In
Changeover time.
Changeover.
Now look at this process. Natarajanji, what is the changeover time?
10 minutes.
10 minutes.
Only
And what
10
is the
minutes.
uptime?
90%.
90%.
So if you are to improve this, what is to be improved? Machine health.
Asset medium.
Machine health, the uptime needs to be improved. Similarly here, look at this. Uptime is only 80%. That means downtime is, in this, downtime is 20%. That is
20%.
immediately prompting you to take care of the machine health. Yes or no? Maharajji, Varun, Shakti, Mani,
Yes, yes,
please
yes,
confirm.
Yes, sir.
Yes, sir.
Yes.
So now can you see that when you are plotting this value stream map, you are not only, my dear friends, gaining a good knowledge of what are the sequential process stages, but my dear friends, you are also getting an extremely beneficial insight into how the process can be improved. What exactly shall be done on process A, you now know. What exactly shall be done on process B, you now know. And what exactly shall be done at process C, you now know. Yes or no? Show me a confirmation. And that is why, my dear friends, it is different from a simple process flow map or simple process flow diagram. Because on a superficial level, Udayavani ma'am, Shova ma'am, Varun, Shakti, please come
Yes,
on
sir.
screen. Please come on screen
Yes,
so
yes.
that I can see your happy faces if you are happy. And if you are not happy, then you can remain off camera. I don't want to see sad faces. So if you are getting everything and you are happy, please come on camera so that I also become happy.
Yes.
Everyone becomes happy. This becomes a happy
Yeah,
situation.
yeah, sir. Hi.
Okay, that's great. So, my dear friends, can you now see that it is much more influential, much more insightful tool that helps you understand not only the sequential process stages, but exactly how every process stage is behaving. Is there a line? Is this the line balanced? Is it is working to the tune of takt time? Is the flow established? And what exactly are the steps that we need to carry out for making improvements in every process stage? And that, my dear friends, is the beauty of the value stream map. You can also add a couple of more information points here in this data box. Do you think it is a good idea that if I can add the rate of yield, the good product percentage also in one data box, so that I can know if the process quality is to be improved? So some process experts also do that. When I personally carry out process this value stream mapping, in addition to these, I also write down the percentage yield at this process stage, so that I can also work out whether the quality needs improvement at this process stage or not. Is that clear? Varun, Shakti,
Yes, sir.
Parimala ma'am, please confirm. Is that clear? Shova ma'am, Vignesh,
Yes,
is that clear? So we have now understood the benefit of having this way of understanding. Now, can you look at this? This is set, this is process A, and this is a symbol which says that this is about the operator. If there are more operators, let us say 2, then we can write here 2 or 3 or 4. So,
Here, actually, you have to put 2 only, sir, because 2 shifts, 2 operator.
yes, but the for one shift, how many operators? That is what the interpretation is. So once this machine is running, at time there are certain machines which require 2 operators parallelly if the machine is too big, right? So therefore, it is a convention to really mark how many operators at a given point in time are employed on this machine. Natarajanji, that is a norm,
Yeah, okay.
right?
So
So
for a big process, the whole line will consist of 4 or 5 machines.
yes, so
So
sometimes
there will
yes,
be 3 or 4 operators for
yeah.
each
So
stage.
sometimes, and therefore it is not really talking of a machine only. It is talking of a sub process. Varun, thank you very much for bringing this out. So for some machines, so we can go to the machine level value stream map also. We can go to the sub process value stream map also. So this is a sub process level value stream map. Everyone is clear about this? What is the meaning of this? 1780 pieces stored here in this bin. So there is a WIP bin here, there is a WIP bin here, there is a WIP bin here, there is a WIP bin here. WIP is work in process inventory. Now let us have a look at this. Zoom in is here. I will zoom out. No. Okay. So now, my dear friends, can you see what does this lead time ladder means? Lead time ladder. Can you see this lead time ladder?
Yes.
So this inventory before even the process starts, there is a 6 days inventory. So let us try and understand on the basis of the throughput time calculations that we did yesterday. So one piece spends 6 days in the inventory here. Natarajanji, Parasji, please confirm. We are tracking
Yes,
the
sir.
life of one piece. We are tracking the life of one piece for calculating the throughput time. That exactly is the exercise. Uday ma'am, please come on screen. I will need your support here. I want to calculate the throughput time, which is I will calculate how much time one particular piece will spend. Okay, so this one particular piece spent 6 days in this WIP bin, then 300 seconds in the process. Varun, yes or no? Then 4 days in WIP bin, then 45 seconds in process B, then so many seconds here in process C, then so many days here. So, can you calculate?
It's 14 days by 85
Yes.
seconds.
Can you calculate? So the production lead time is what? Production lead time is 14 days. 6 plus 4 plus 1 plus 3. Even seconds I have. Seconds were negligible. So therefore I have not taken into these considerations. They are insignificant when we are talking in terms of days. So what is the production lead time, also known as throughput time here? Parimala ma'am? 14 days. Whereas what is the actual time when it is getting processed? 300 seconds here, 45 seconds here, 240 seconds here, 585 seconds. Now and can you see that if this would have been a single piece flow arrangement, the throughput time would have been only this 300 seconds plus 45 seconds plus 240, only 585 seconds. Yes or no? So now can you see that on this lead time ladder we plot two things. We write down what is the production lead time, and we also write down what is the processing time. Now I want all of you to have a deep look, and I have intentionally made one mistake here. Please check and tell me. Cycle time 300 seconds, therefore this spends 300 seconds. Cycle time 45 seconds, therefore it spends. Varun?
Process C.
In the
Like,
cycle
no,
time of
put
the term of
change
300
over time.
seconds.
Change over time
No,
you
no, no, no.
mentioned.
No,
Here is
300 seconds.
240.
300 seconds.
240 is 300.
240 and 300. So
300.
therefore, what this is wrong. Yes?
Yes.
Yes? So
It should
there
be 300. It is
it
wrongly.
shall be 300. Either this is to be 240 or this is to be 300. Yes? So we are
Oh, yes.
taking up information from this data box and creating our lead
Ladder.
time ladder.
Lead time ladder.
Lead time ladder. Everyone can now see? Everyone can now see the beauty of this value stream map. So many things, my dear friends, it is telling you. Yes or no? And please also note that yes, we have just starting with a beautiful process flow map that has already been created, but this is quite a task. We will have to study each process stage to be able to know that what is the cycle time, what is the average changeover time, what is the uptime, how many seconds are available, how many operators are required, what is the rate of quality, that is the yield percentage and all. Yes or no? Can you see that? And then this gives you lot many great insights into the process.
Sir,
Well,
could you please tell again this 240 which we wrongly mentioned or
intentionally mentioned wrongly to check whether you people are attentive or not. Varun bhai, are you attentive? Please tell me
yes,
if this
yes.
was.
So I calculated that as per this ladder diagram, the 5
Yeah.
585.
Yes. So the point is that what we do, we create our
It
data
is
boxes.
645.
Yes.
Sir, I just have one doubt here.
Yeah,
Sir.
please ask, ma'am.
So the customer is placing a monthly order to the production, and
Mhm.
production is giving a weekly order to the supplier. And looking at the production lead time, it is 14 days.
Mhm.
So how will the customer's orders be maintained or delivered on time? There will be a large delay in it, right?
Only no. You have slightly misinterpreted the whole thing, because typically what really customers do, they say that I want this much volume every month. Now that is broken down into the weekly
Okay.
schedules.
Okay, sir, got you.
Right? Okay, perfect. So that is how.
So, if you're buying full material on a monthly basis,
Yes.
the amount will be there added up. So instead of that, they will split the quantity in the weekly basis, so the amount will be very, and the
Exactly.
transaction money will be very less.
Okay.
Exactly. Perfect. Excellent. And I want everyone to clap for him. He gave us the correct reasoning that why we are breaking down the monthly schedules into weekly schedules, so that we can reduce the cost that is blocked in the inventory. Right? We will procure also in small batches. Can you see that? We will not only, just as Paras Bhai is very correctly mentioned, we will not only process in small batches, we will also procure in small batches. Delivering in the small batches or not is up to the customer, whether he wants it to be delivered in small batches or whether he wants to deliver it in large batches, that is up to him. But definitely as an organization we can process in small batches, yes or no, and we can procure, and we shall procure in small batches, yes or no. Show me a thumbs up if everyone is clear about that. Perfect. So my dear friends, that takes me to the next and very important characteristic of a value stream map.
Sir, kindly put into the presentation mode, sir. Very small. I'm not able to read in the screen actually.
Right now it is in the presentation mode only.
Yes.
Isn't it?
Yeah.
But I'm not getting a full picture of it.
Everyone else, can you confirm it is in the presentation mode only?
Yes.
It's a presentation mode only.
Yeah.
The font size to be increased.
Okay, so maybe I will, after the session is closed, I will increase. I have intentionally reduce the font size, because what I am doing, on half the screen there is text and on half the screen I can look at your faces. If this was to fulfill the whole screen, then maybe I will have to not I will not be able to view you people. Okay, anyways, so my dear friends, this brings us to a very interesting and very important aspect of value stream map. They always work in pairs. We create a present state value stream map, and we also create a future state value stream map. Only a present state value stream map will give us very limited benefit. The actual benefits that we can gain from this tool come when we are able to draw a future state value stream map. Also, that means that the kind of value stream map that we would like to have. What can be certain characteristics of the future state value stream map? It must be balanced. Natarajan ji, Paribala ma'am, Shakti bhai, Varun, yes or no? It must be
Yes.
balanced. And just as Natarajan ji was mentioned, it must be taking care of elimination of the waste. Right?
Sir, in balancing, we cannot go equally balanced in some cases or most of the cases.
Yes,
So
we cannot.
what will be the percentage? What is the nearest percentage we can?
You see, the base logic is that all the cycle times must be less than or equal to the takt time. That is the first significant decision making point. Yes or no, Varun? All the
Yes.
cycle times must be less than or equal to the
Takt time.
takt
Takt
time.
time.
That is fact number one. Fact number two. Now, if you are able to visualize that particular map where we say that the cycle time of one process is 300 seconds and the cycle time of the next process is 45 seconds, then please tell me that can I stop my process 2 for, let's say, 2 hours, send both the operators on the process 1 if that helps increasing the productivity, and create necessary stock. So sometimes we intentionally create that situations where certain machines are not operated 100% of time. Varun, can you see that? The process B is not required, and therefore it shall not be run for the 100% of available time. We shall run it only to meet the takt time and allocate the resources elsewhere. Varun bhai, can you visualize that?
Yes.
Yes, and that, my dear friends, is exactly the concept that Dr. Goldratt told us when he taught us the theory of constraints. He says that maximizing the local efficiency of each process stage is a ridiculous concept. We must exploit the bottleneck. We must assign the maximum possible resources to the bottleneck operation and make sure that the bottleneck operation is producing at the best rate it can produce. Can you see that? So there is no thumb rule as such that the line has to be balanced to 80% or 90% or whatever. Two guidelines. One, that each and every process shall be able to meet the takt time. Fact number one. And fact number two, once you have identified the bottleneck, all the resources shall be exploited to maximize the output from the bottleneck. Okay. Now, coming back to our concept of value stream mapping, present state and future state value stream map. So, almost always what we do create a future state as well. Now, who will read this out? Varun or Paribala ma'am? Paribala ma'am, can you
Yes,
read
sir.
this out? Yeah, please read this out.
Value stream mapping, present state and future state maps.
Yes.
Value stream mapping, VSM, is a tool to support plant in a organization and is split into two views, current and future state maps. Next also, the two are not mutually exclusive. In fact, while a current state VSM is worthwhile to gauge your existing process, it is only by setting out the desired state, the future or ideal state, that you can know where you aim to be and ensure your process improvements are fruitful. Indeed, transformation is at the heart of the VSM.
Yes. So exactly. Thank you very much, Parimala ma'am. So thank you very much for explaining all of us that in the value stream mapping methodology, there is always a present state map and a future state map. Present state map tells us exactly what is the present status, what are the various sequences, and future state map is how we want our process to be, including some of the concepts that we just discussed. It shall be according to the takt time, there shall be balance, there shall be waste elimination, just as Natarajanji had identified in the very beginning. So when we look at the value stream map, we simultaneously create a future state map, and this is one of the examples of the current state, and I will take you through the learning process by which we will create a future state value stream map. Please have a look at this. This is the symbol for material flow or information flow. Information flow. Yes, this is a symbol for information flow. So initially information is coming from the customer, going to the production control. Production control is giving information to the supplier. Then it is coming to the manufacturing process. In this manufacturing process, who will help me with this? Sampath bhai, what is the first process? What is the name of the process? What happens here? Lead plates manufacturing.
Lead plates.
Next process is plates cutting and
Plates.
firing. Next process, third process is battery assembly. Next process is battery charging. Next process is shipping. What is the symbol? This symbol is for material transportation. This was the information flow, and this symbol is for material flow. Now look at this data box and please tell me, what is the cycle time?
4 hours.
4 hours. And what is the lead time that happens before this, right? So there are various different symbols. So when they say this L/T, which is lead time, that is happening before this processing operation. So 6 times 6 hours is here, then 4 hours is here. Oh sorry, after this, the lead time after this. So 4 hours is here.
Cycle time.
Cycle time, one particular piece will spend how many hours here in this machine? 4 hours.
4
And
hours.
how much time it will spend in waiting? 6 hours.
6 hours.
Here, what is the cycle time? Please tell me, what is the cycle time?
26 hours.
Therefore, how much time a particular piece will spend on this process stage?
26 hours.
26 hours. And how much time it will spend after this process stage? In
40
waiting?
hours.
40 hours. And so on. Now, can you see how many operators at any given point in time work on this machine?
All right.
How many operators at any given point in time work on this machine?
4.
How many operators at any given point in time work on this machine?
4.
How many operators on a given particular time work on this machine? 2. What is the please tell me if this is the good percentage that I receive. Yield. What is the yield percentage here?
97%.
90. What is the yield percentage here? 95.
95%.
What is the yield percentage here?
92%.
What is the yield percentage here? 100%.
98.
Now looking at this, please tell me that which process is in the very serious need of improving the quality performance. Which process stage?
92%.
Yes,
Battery assembly.
this process stage needs a
Battery assembly.
this process stage needs a drastic improvement in the quality performance. Varun, Rajanji, Akanksha, can you see that? Now please tell me which machine is having the highest cycle time. This or this or this or this or this.
Second one, 26 hours.
26 hours. So which process stage is in a desperate need of improving the cycle time? That is reducing the cycle time.
Second.
Process
Battery
number two.
States curing and drying.
Yes, curing and drying. Very correct. So can you see the insights from this? And now if I ask you to calculate the throughput time and the, please make the necessary calculations. Help me do that. So what is the total cycle time here?
Your voice is not clear. Yeah.
What is the total cycle time here?
Your voice is breaking now.
What is the total processing time here? 4 hours plus 26 hours, 30 hours plus 8 hours,
Yes.
38 plus
38
12
hours. 50 hours.
and this 3. So
53.
total
Yeah,
cycle
53
time
hours.
is, total processing time is
53
53
hours.
hours right now. And what is the total lead time? The time it takes for one particular piece?
85 hours.
85 hours.
85 hours.
Right? We can,
Waiting hours.
yes, we can calculate that. Yes or
85.
no?
46.
Yes, we can calculate.
70, 84 years. 85 years.
85 hours. So when
It's
we
actually
have
86 coming.
maybe it must not be. Okay, but whatever.
85 hours.
85 is coming.
Last one is
Sir,
5
can you
hours.
explain what is C and DA? What is mean by C and DA?
C&A here is representing our yield percentage. How many, what percentage is good product? It is tracking of the
Any
quality.
abbreviation, sir? C and A. We are not getting.
No,
that
I
exactly.
am not aware. I just guessed that because in the next slide you will see that when we have identified the improvement opportunity, this says that the improvement opportunity exists here. One improvement opportunity exists here, so we can avoid unnecessary transportation of the plates. And here one improvement opportunity exists, which says that reduce the defects. So from that, Shakti Bhai, I guess even because this is very unheard of abbreviation C&A. At least I have never heard that. But I kind of made a guess that since they are talking of the improvement opportunity of reducing the defect, they must be talking of this, right? So okay, so looking at this, we have now identified the various improvement opportunities. Those are to be marked there, and based on those improvement opportunities, so can you see before improvement what is the situation here? What is the total cycle time? 53 hours and total lead time 85 hours. That is exactly what we calculated. And after the improvement, this is our future state. This is what we desire to achieve. We will find ways to reach there. We are not yet there. Can you see that? We draw future state map in the very beginning of the project. We are not yet there. But we definitely believe that that is where we want to reach. Now, they have made a lot of improvements. Can you see? Can you see what was here
Yes.
earlier? 26 hours. What is here now?
10.
10 hours.
10 hours. What was here? Your C&A was, how much was that?
95%.
Here C&A was, let's say yield, let us say it
92%.
stands for yield has been increased to
98%.
98%. Similarly, after improvements, when we reach our future state map, now can somebody help me calculate what is the revised cycle time or the processing time. Let us calculate 4 plus 10 plus 5 plus 12 plus 3. Somebody please do the needful. This is 40,
34.
34
34 hours.
and the total lead time
34.
4 plus 6 plus 10 plus 12 plus so on. So it is now 51 hours. How much improvement we are targeting in the cycle time? 36%. How much improvement we are targeting in the lead time? 40%. So my point is that when we have created our present state velocity map, and when we have created and when we have identified where the opportunities for improvement lie, then we create our future state map, and then we work on these opportunities by way of making process improvements, kaizens, problem solving methodologies, and then we reach our desired state. Can we just have a quick look once again and follow the whole process? This is your
Current state.
current state. Can you identify opportunities for improvement here? Yes. Where are the opportunities for improvement? Here. Yes.
28 hours.
And then here also, can you see? Very long.
Lead time.
Here and here. And then you can
Long.
see opportunity for improvement is here. Right? Based on that, you have identified where the opportunities exist. Then we work as a team on this. We find out the ways to improve the process. We find ways to bring it under better control. And then we reach this future state. Everyone clear about this? So now, can...
Yeah, I have one doubt.
Please ask.
Yeah, actually, yesterday we discussed about the lead time. As per the lead time, it is starting to end of the complete process. Here we are discussing value addition or non-value addition like that. The lead time is coming in the bottom. So the yesterday description of lead time and today what we are seeing in the value stream mapping, that is entirely different. Can you explain about that?
No, it is one and the same. It is one and the same. Yesterday I took you to a even detailed description when we were talking of the pre-processing operations also. Remember those yellow boxes? And post-processing operations also. Sometimes, just as in this value stream map, this is called, what we are discussing, throughput time, also known as production lead time. Shakti, does that answer your question? Sometimes what we call
I will read what yesterday we discussed the description. The lead time and the throughput time. The lead time means the total time travel interval between the demand and the delivery, including order processing, incoming inspection time, throughput time, and transport time to customer time. So these are the complete description. Yesterday we discussed what we discussed there. Today I am seeing that in our value stream mapping. So only the waiting time calculated is showing as lead time.
Yeah, this is production lead time. In our terminology, it should have been called the throughput time. In the definition that we discussed yesterday, it shall be called throughput time. Some of the Japanese people call it production lead time also, and therefore they have roughly used this term lead time. Ideally, it should have been called the throughput time only, because this fits into our definition of throughput time only, not in our definition of lead time. Shakti is very much correct. Yes or no? Can everyone see that? And we must congratulate him for being so sharp in observation. So what is written here as lead time is actually not lead time as per our definition of yesterday. Which definition it is meeting? It is meeting the definition of throughput time. Yes or no? It is meeting the definition of throughput time. Okay. Sometimes...
Sir,
yes, please.
Here in the lead time, we are addressing 6 hours, that is, which is the waiting hours, right?
Here, this one.
In the first, yeah.
Yeah. So after this, there are, you see, There is no really a textbook that explains. So various different organizations use different design of data boxes. So this data box is designed in such a manner that it says that what is the waiting time here after this process, right? And this has been now made very clear when they are making this values, this lead time ladder, right? Hope the we are getting the figures right, and we are not getting confused only by the nomenclatures, right? If we are clear about the concepts, sometimes people might not use the exact nomenclature, but the calculations and the implications and the meaning we must be able to understand and appreciate. Can everyone understand the meaning of how much time a particular piece will spend? How much time is when it is being processed and all. Okay, now, so this is the future state, and this we discussed yesterday also. Now within the processing time also, as I discussed yesterday, please tell me that when some, and I will take rather more simpler example here, when a particular piece, look at this, when a particular piece is spending 300 seconds here, right? That means every 300 seconds one piece is coming out of this machine. Within this also, within these 300 seconds also, there can be some non-value adding activities happening. Can you see that? A particular piece is spending 300 seconds here on this machine's platform, but out of those 300 seconds also, there is a possibility that some of the time is being lost as non-value adding time. I will give one example. Let us say this is where I want to drill a particular piece of metal. If I tie my drill bit here and this much distance is travels in air before it starts removing the metal, this time this is traveling in the air, is it a value adding time or a non-value adding time?
Non-value adding.
Non-value adding time, which can be somewhat reduced, that instead of tying my tool here, can I tie my tool here?
Yes.
Then the time it takes into traveling into the thin air is reduced, yes or no?
Yes.
And is that gives you a kind of input that how to improve the, how to increase the output of this machine. So if we are able to even look further into the processing time, we will able to identify value adding and non-value adding activities. And if we are able to eliminate the non-value adding activities, the cycle time will reduce further. The point I want to communicate, Shakti ji, and I want your inputs also on this, that do you agree that out of this 300 seconds that a particular piece is spending on this particular process, is all of 300 is necessarily a value adding time, or it can be a combination of value adding and non-value adding activities? Can be a combination of, Shakti bhai, can be a combination of value adding and non-value adding activities.
Yeah, possible.
Possible. And if we are able to detect non-value adding activities and then eliminate those and maybe bring this down from 300 seconds to 250 seconds, then what will happen? This machine will throw out a piece every 250 seconds. Yes or no?
Yes.
Right? So, in addition to being able to identify that what is the cycle time, we shall then be able to find out what are the value adding and non-value adding activities. Also, now if you are ready to further deep down and pay 100% attention, I will then try and explain how do we calculate the cycle time. Ready? Show me a thumbs up. Show me a thumbs up. How do we calculate the cycle time? But before that, let me just recall how do we calculate the throughput time. Throughput time, how we calculate? We look at one particular piece and track its journey throughout the production pipeline. So we pick up one piece, it spends 3 days here, 300 seconds here, it spends 4 days here, 45 seconds here. That is how we calculate, my dear friends, the throughput time. That is our technique, that is our mechanism for calculating the throughput time. Now, since you people have confirmed that you are now ready to learn how to calculate the cycle time, show me a thumbs up once again, and I will then take you to the how do we calculate the cycle time. We study, let us say, the whole machine for 8 hours. We must study the whole machine for 8 hours. How many minutes are there in 8 hours? Let us say the machine is
480.
operating.
480.
The machine is
480.
operating for 8 hours. The machine is operating for 8 hours. How many minutes are there in 8 hours? 480
480.
minutes. So on the one hand, we have noted that this machine has run for 480 minutes, was under operation for 480 minutes in this shift, and it has given me 320 pieces. 320 pieces. With these 2 bits of information, how many hours, how many minutes machine was run? 480. How many
Yes.
pieces it has given me? 320. We calculate our cycle time. This much time per piece. Yes or no? So 480 divided by 320. How much that comes? Parimala ma'am? What is the cycle time? I am giving you 2 pieces of information.
1.5.
Yes, I am giving you 2 pieces of information. 480 minutes, 320 pieces. That means, what is the cycle time?
1.5 minutes.
1.5 minutes. Yes or no? Now,
1.5 seconds.
minutes. I've been talking in terms of minutes. 480 minutes, 320 pieces. Yes? I've been talking in terms of minutes. So 480 minutes, 320 pieces. That is cycle time is 1.5 minutes. Now, we will look further into this. Out of this 480 minutes, let us say that 120 minutes the machine was under breakdown, and therefore it was not able to produce. Can you see that? Out of this 480 minutes, when I started my clock in the morning and when I closed my clock in the evening, how many minutes? 480 minutes. Out of this 480 minutes, this machine was operational only for 360 minutes. Uptime was only 360 minutes. So, if I want to improve, given this situation, Shakti bhai, Sampat bhai, Varun bhai,
Yes.
Bharat bhai, Natarajan sir, given this situation, if I give you the task that Shakti ji, please give me more production from this machine, what will be your action? You will improve the health of the machine. You will reduce the breakdown time. Yes or no? Given this situation, if I give you the task, Shakti bhai, that Shakti sir, please help me increase the output from this machine, what will be your action plan? You will look at the data. You will say, Vivek bhai, out of 480 minutes, your machine is under breakdown for 120 minutes. So let us focus on reducing the breakdown time. Yes or no? That will be your initiative. And based on your initiative, suppose we are able to run it for another, we are able to reduce the breakdown time to, let us say, bring it to 0 for the sake of simplicity, then it will be producing more. Yes or no?
Yes.
That also means that it will be cycle time will be reduced. Yes or no? So, what is that mechanism of calculating the cycle time that holds the insight into how to improve the cycle time? Can you see that? If you have understood that how we calculate the cycle time, total number of minutes spent divided by total number of pieces produced, which also includes your breakdown time. So it tells you that let us reduce the breakdown time. It will also tell us let us reduce the changeover time. It will also tell us let us reduce the setup time. Right? If those breakups you are able to find in this, can you see this? So out of this, let us say in the process one, this is about, do not really match figure to figure, this is some other calculation. But in this Yuma-Jumi chart, can you see that this is these red blocks I am representing for breakdown time and changeover time. That is a time lost. Breakdown time is a time lost for you. Yes. Changeover is a time lost for you. Yes. Setup is a time lost for you. Sampath bhai, Shakti bhai,
Yes.
Paras bhai, Varun, Mani bhai. Can you see that? Natarajan ji, Shobha ma'am, Udaya ma'am, can you see that? So if I am able to break down that this is my productive time and this is my time that has been lost, this gives me immediate insight into how to bring my processes below the takt time. Can you see this particular operation 2 is having more cycle time than the takt time? And do you now know that what is the way, what is the path available to you? You already know that this is the time lost. So much breakdown is happening. If you are able to remove that, then that is how you will bring down your process. So non-value adding and value adding processes. Maintenance is value adding or non-value adding? Please tell me.
Value adding, sir.
Maintenance.
Non-value adding.
Yes, breakdown maintenance is non-value adding. Now please tell me, what is your take on changeover? Value adding or non-value adding? Or value enabling? Please remember, this is a trick question. And please remember,
Value enabling.
value enabling. Value enabling. And what is the meaning of value enabling? Non-value adding but necessary.
Is a necessary non-value added activity.
Yes, non-value, very correct. Non-value adding but necessary. So first attack shall be on those activities which are non-value adding in black and white, like breakdown maintenance. Yes or no? Breakdown maintenance is non-value adding activity. Eliminate that. Waiting is a non-value adding activity. Eliminate that. Searching is a non-value adding activity. Eliminate that. Transportation is a non-value adding activity. Eliminate that.
Waiting.
Inspection.
Now I will come to that. So first there are certain activities which are not in gray area, which are very clearly non-value adding activities. For example, breakdown maintenance. For example, transportation. For example, waiting. For example, searching. They are obviously non-value adding. Eliminate that. Then once you are done with that, then let us focus our attention on those activities which are somewhat in gray area, somewhat debatable. For example, you have mentioned inspection. So in my opinion, until unless you are able to achieve a operational excellence level, inspection also is a non-value adding but necessary activity. Can you see that? Until unless you have achieved the best and highest levels of judoka, we discussed with that discussion with Parimala ma'am, built-in quality. So until unless you are able to achieve that 100% assured built-in quality base, which is system driven only, for some time even the inspection is necessary. Although I understand and agree that it is a non-value adding activity.
In
Similarly,
machining process also, the loading, unloading, cleaning are all called necessary non-valued activity.
exactly, perfect, very good, very good, very good for this example, sir. Thanks a lot for this. So there are certain activities which are non-value adding but necessary. So first, which are the activities you eliminate, which are clearly non-value adding? Then,
Sir, for value enabling, you have given one example, that is preventive maintenance, right?
pardon?
For value enabling activity,
Yeah,
which are the activities we consider under this?
just as example, Natarajan sir has given. Natarajan sir, the example you have just given: machine loading, unloading,
Machine loading.
bin
And
cleaning,
preventive maintenance also come in
preventive
there.
maintenance also. So then we will have to find out what are the mechanisms by which we must reduce the time they take. Can the preventive maintenance done faster? Right now, let us say it is taking 4 hours for preventive maintenance. Can we find ways by which it can be done in 2 hours? Yes or no? Right now, let us say we take 1 hour for loading a particular piece, just example that Natarajan sir has given. Can we find a way by which it can be reduced to half an hour? On the other day, who was there? Maybe some ma'am was there who mentioned that they take lot of programs from the cloud servers, which is also a necessary activity. But then we discussed that can we have better internet connectivity? Instead of using 3G, can we use 5G so that the programs are downloaded faster from the cloud servers? Yes or no? Who was that? Shova ma'am, was it you? Udaya ma'am, was it you? Somebody was there who mentioned this particular, who gave this particular example. Yes, Vignesh, you want to ask something?
Yes, sir.
Yeah,
Sir,
please.
inspection is a non-value adding but required. That is that that area only I have some doubt. If in case customer costing included in the inspection, that time that is a value adding in a single time, in the first time. If again retrofit or re-inspection time, that is a non-valued activities but required. First inspection including the costing means that is a value adding. I think it's wrong means can be corrected, sir.
You're right, but there is another way of looking at. There is another way of looking at the whole scenario. Vignesh, just as you have very correctly mentioned that the re-inspection definitely is a non-valuating activity. I agree.
Inspection itself, it is non-value added. How come it is going for the re-inspection? The basis inspection is non-value. We should not
Sometimes,
calculate it.
yes. So my point is that till that time that you have achieved you have perfected your system, your process to that level, when the defects are not happening at all. Let's say you have achieved 6 sigma performance and you are getting 3.4 dpmo results, then inspection is obviously non-value adding. But in a typical scenario, let us say when we start our lean implementation process improvement projects in an MSME, and let us say at this point in time the yield percentage is 98.5%. Let us take this case scenario, Parasji. The yield percentage is 98.5%. That means 1.5% pieces are defective. Do you think that we can take a risk and ship them to the customer?
No.
Or no, we will not take that risk. Therefore, at this present level of performance, when the yield is 98.5% or 99%, and we do not want to take that risk of shipping defective pieces to the customer, we are forced to have this activity of inspection, which we are saying that it is a non-value adding but necessary at this point in time. Yes or no? And then we will do two things. We will improve our processes further and further. We will go for built-in quality, so that, and we will go for, let's say, Six Sigma performance, do all those improvement initiatives, so that our quality output itself becomes so good that it will not require inspection. That is the aspirational level. But in most of the cases, especially with the MSMEs, especially when we are just starting our improvement initiatives, then it will be a necessary, although non-value adding activity, and therefore it is called a non-value adding but necessary activity. And that is exactly the reason why I do not personally like to call it a value enabling activity. Can you see that? That Parasji, inspection can never be called a value enabling activity. But
The customer will not pay for that.
yes, so it can never be called a value enabling activity, but yes, in certain circumstances, it can be called non value adding but necessary at this point in time activity. Do you agree with that? Show me a thumbs up. Who all are agreeable with me? Okay, so that was exactly what I wanted to discuss with all of you in value stream mapping, and I'm very glad that we developed quite a good understanding about how the value stream map works. And I must once again thank all of you for making this such a lively, interactive discussion, which has helped us really gain deep insights into how to create value stream map and how to make uh, any sense of the value stream map, how to identify the waste there, how to identify the improvement opportunities there, and how to really balance the line, create flow, all those aspects. So, may I request all of you to once please come on camera so that I can call the session off for today before
Sir,
you go for lunch.
sir, I'd like to have, yesterday also I requested you for the formula, cycle time, that number of minutes divided by the pieces, like that. We have a formula of takt time, whatever things. Could you please share on that screen so that we can take it note down that?
Maybe tomorrow when I join. Right now, I do not have that with me. I will share that with you.
Okay. I have
Okay.
seen some more slides. You have the formula.
Yeah, I will share the whole presentation with you. The point is
Okay.
that it is not really necessary to discuss each and every slide. I will share the complete presentation definitely with you, so you can have a look at your own free time. And I am very sure that we have discussed in depth whatever is required to be understood. And thanks a lot for everyone, especially to Paras ji and Sampath bhai, Parimala ma'am, Vignesh, Shakti bhai, Shova ma'am, Natarajan ji, Varun, Mani, Siva, Udaya ma'am, Aditya and Prasanna were mostly quiet, but yes, their presence was motivating me. Anyways, thank you very much. Thank you very much, and just give me a
Only one doubt.
yes, please.
Last. So, what is the difference between Makikami chart and value stream mapping? So, Makikami chart also we are mapping as that value added, non-value added, and what are the activities the end-to-end like complete throughput processor.
So one significant difference is that they are not really plotting your lead time ladder. Lead time ladder immediately prompts someone, people who are creating the value stream map, that immediately prompts them to find ways where the throughput time and thereby the lead time, as we discussed yesterday, can be cut. And the other chart, Makikami, that you discussed is more about line balancing and matching them with the lead time. So that is less focused on cutting on the throughput time and the lead time. Whereas this chart, value stream mapping, is equally focused on both the aspects.
WhatsApp group not formed, I think. Anybody can take the initiative and they can form WhatsApp number so that we can share the experience and knowledge.
Yeah, so somebody will have to take the initiative from your side, because I do not really have the WhatsApp number of all of you. So somebody please take the initiative and then add us there. Okay, so then.
Send the number in
Oh,
chat.
okay, so we'll coordinate that. We'll coordinate that, and as I mentioned, that please be very, very active on the LinkedIn, right? And please take time to really connect with us, with GSK sir, Veer Raghavan sir. He's very, very active on. Veer Raghavan sir is very, very active every other day. No post, and they are very much insightful. Okay. So thank you friends. Thank you friends. I will hand over the session to Veer Raghavan sir now. Veer Raghavan sir, can we go for a break? I will make you the host, sir.
Yes, sir.
Yes. So Veer Raghavan sir, I have made you the host, and then I am taking your leave, and
Yes.
we will meet tomorrow. Okay. Good night, friends. Good night.
Right, sir.
Yes, thank you.
So we'll take a short break.
Thank you, sir.
On 8:45 we'll meet again.
Okay, sir.
Okay, sir.